In this example from chapter 11, we have information about the beta, the market return, and the risk-free return, and we want to know what the expected return on this stock must be. So the equation that we're using is the SML equation, or the standard market line equation from the chapter, and we're going to rearrange that equation to solve for the expected rate of the return. So if you have your formula sheet for chapters 10 through 11, you see that the security market line is the expected market return minus the risk-free rate divided by beta. And so we're going to rearrange that equation. So we're going to be looking at the risk-free return plus the beta times the difference between the market and the risk-free return. So this also where the expected stock return is a calculation of the what the market rate is versus the risk-free return. So remember, the risk-free return is the percentage of return that's currently on treasury bills. That is the standard risk-free rate that is used in stock calculations. So we have the risk-free return plus the beta times the difference between the market return minus risk-free return. And that gives us the expected return on the stock, which is 11.92%. In the next example, we're going to do a very similar equation, but we're going to solve for something else. So now we have the expected return of stock, the risk-free return, and the market return, and we want to know what the beta is. So we need to rearrange that equation again. So for the beta, we have the stock expected return minus the risk-free rate divided by the market premium. So the beta of this stock is 1.13. In this example, we have the stock expected rate of return, the beta coefficient of the stock, and the risk-free return rate for treasury bills. And we want to solve for the market return. So we rearrange that equation again. And in this case, we have the expected return on the stock minus the risk-free rate divided by the beta plus the risk-free rate. So the expected return on the market as a whole in this situation is 11.8%. For our last example from chapter 11, we have information about stocks betas, the expected return on the stocks, and the total of the portfolio beta. So the beta of stock J is above 1, so it's riskier than the average stock. K is below 1, so it's less risky than the average stock. And we have weighted our portfolio so it equals 1, which is average risk. So we want to know what the weight of stock J is. So the weight of stock J is the portfolio beta minus stock K beta divided by the difference between J and K. So J minus K. You can see this is similar to the first couple of examples that we did when we were calculating the weight. Okay, so we have the weight of stock J. Now the weight of K is the remainder of the portfolio. So we know that the two weights have to add up to 1. So 1 minus the weight of stock J will equal the weight of stock K. Now we're going to calculate the expected rate of return on the portfolio. So remember, that's the weight of the stock times the expected return of the stock. And then we add those results together. So we have two stocks. The weight of J times the potential return or expected return on J plus the weight of K times the expected return on K. So the expected return on this portfolio is 11.69%.